Okay, so everybody should see this. It says section 1.1 notes, properties for exponents. And we're first going to just talk a little bit about what an exponent is. And we're going to look at two rules that I want you to know. You may have been exposed to these rules before, but the product rule and the power rule are important to know how to use and when to use them. So first, you learn how to add, right? If you have like 5 plus 5 plus 5 plus 5, and if you have repeated addition, we said, hey, there's got to be a better way to do that, right? And so then we do what? We multiply. I only do 6 of them. So we got 6 5s. So instead of adding 5 plus 5 plus 5 plus 5 plus 5 plus 5, we could do 5 times 6 and get 30, right? So multiplication is a short way to do repeated addition. And then we have multiplication, and we may have repeated multiplication. So we'll say we have 5 times 5 times 5 times 5 times 5 times 5, 6 5s. So instead of having to write that out, there's a short way to write that, and that's when we use exponents, and we say, well, that's the same thing as 5 to the power of 6, right? And that's all an exponent is. It's a short way to represent multiplication, repeated multiplication. And multiplication is a short way to represent repeated addition. So number 2 here, 2 to the 4th power means 2 times 2 times 2 times 2. We got 4 2's that are being multiplied together. And what's that going to multiply out to? 16. So in general, on number 1 here, A right here is what we call the base, and then B's our exponent. And so this would mean we have A times A times A, and it keeps going B times whatever B is. Okay. So this is what it means to be an exponent, and sometimes it's always good to know what it means because it gives understanding behind things. But sometimes just relying on that becomes tedious with some more complicated problems, and it's nice to find some shortcuts or some patterns to handle some of the more complicated problems. And so that's where these rules start to emerge. So if we look at number 4, we have 4 to the 6 times 4 to the 3rd. And what that means is, well, 4 to the 6 is 4 times itself 6 times. So that's, we have 6 4's here. Times 4 to the 3rd, well, that's 4 times 4 times 4. We have 3 4's. And so it's just a bunch of 4's that we're multiplying together. So how many 4's do we end up with? We got 6 plus 3 is 9, right? And so this is really going to be 4 to the 9th power, which is a really big number, especially if you don't have a calculator. I mean, if you had a calculator, just type in 4 to the 9th, they'll give it to you. But remember, this is a no calculator unit. And so if you get something like that, just leave it 4 to the 9th. Don't take the time to multiply it all out. If you get something reasonable like 2 to the 4th, I expect you guys get that, right? 16, you could do that. But once the answer is like over 1,000, you could leave it in this form. Okay. So in general, number 3 is going to be A to what power? Do you guys see, if you go look at 4, do you see how we could use the 6 and the 3 to get 9? The shortcut? It would be to add them, right? And so add the B and the C. So A to the power of B plus C. So that's what we refer to as the product rule. A common mistake made on number 4 is when you're trying to use the product rule, people remember to multiply or add the 6 and the 3 and get 9. But then they get a little confused, like, what should I do with the 4 and the 4? Should I multiply them together and get 16? Or should I add them together and get 8? Or should I just leave it as 4? And I hope you can see why we leave it as 4. When we write it out, we get 4 to the 6, 4 to the 3. We're just saying, hey, there's 9 4s. So that base doesn't change. It stays 4. It's just the exponent that changes. The power rule on number 6, going back to the definition of an exponent, well, here we have 4 as a base, but we had 2 exponents, a 6 and a 3. And if we start with the outermost exponent, that 3, that's saying, okay, we have a repeated multiplication. We have 4 to the 6 times 4 to the 6 times 4 to the 6. We have 3 of them that repeat. And then you deal with the 6. Well, what does that mean? Well, that means I have repeated multiplication again. I have 6 fours here, another 6 fours, and another 6 fours. So how many 4s do we end up with? 18. And so our answer is going to be 4 to the power of 18, which again is a really large number. We will just leave it 4 to the 18. In terms, if 4 is your base, the highest I'd expect you to do in your, without a calculator is 4 to the third. What's 4 to the third? You know? What is it? 64. Okay? And then 4 to the fourth, I'll just let you write 4 to the fourth. But if up to 4 to the third, you should know 4 to the third is 64. Okay. So now we got some mixed practice here. And we're going to practice using just these 2 rules. And I want you to start with just number 7 and 8. To give you a little bit of time to try it. You may be wrong, maybe right. So give it a try, and then I want you, after you and the person maybe you're sitting next to have enough time to try it, I want you to compare answers and see if you have the same thing or different. And if it's different, I want you to talk about maybe how it should, why is it different, and what should the right answer be. All right, does anybody have an answer that they feel comfortable sharing for number 7? Yes. 30, a to the 6th power, and that is correct. Good job, Owen, right? And here's one way to view this. Okay, I want you to, when you look at this, don't see it as 2 pieces being multiplied together. View it as 4 pieces being multiplied together. You have the 6, the a squared, the 5, and the a to the 4th. The parentheses don't need to be there. You're going to kind of ignore them. There's just a multiplication sign separating all those. And so you could rearrange things. You could say, well, this is 6 times 5 times a squared times a to the 4th. There's a transitive property for multiplication that allows you to do that. And that's, those of you that are getting this right, that's what you're doing in your head. You're saying, well, the 6 goes with the 5, and I'm multiplying that together to get 30. And the a squared goes with the a to the 4th, and that means 2 a's and 4 a's, so that gives me 6 a's, so a to the 6th power. Okay. Anybody else feel comfortable sharing what they got with number 8? Yes. And what's your name? Alex. Thank you, Alex. That's correct. And here, again, you can rearrange things. You have the 4 times the negative 2. Now, negative 2, I do put in parentheses. You know why? Just because for confusion's sake, because if I didn't, it would look like 4 minus 2. So that one I do want to put in parentheses, just to, without a doubt, make sure, okay, this means I'm multiplying these. And then we got a squared, and I'm going to multiply that with the a to the 3rd. You only multiply same base with same base. And then we have the b times the b to the 5th. And a few of you may have wondered, what do I do with that b? What's the exponent? But remember, exponent is just talking about how many do you have? Well, how many do we have? It's only 1. And so if you see it, by default, it has an exponent of 1. That 4 has an exponent of 1. The negative 2 has an exponent of 1. We don't typically write those, but they're there. And so now you can see, okay, 4 times negative 2 is negative 8. We got 5 a's. We got 6 b's. You guys remember what anything to the power of 0 is? 1. Okay. That rule is not as intuitive, but you just got to remember that. Anything to the power of 0 is 1. Number 10 and 11, I'm going to give you a time again to try that. And after you have time, again, I want you to compare with the person next to you, if you guys have the same thing. Okay, so I saw this. 2y to the 3rd, you guys agree? No. Tempting, but no, right? It should be 2 to the 3rd power, y to the 3rd power. Because this means 2y times 2y times 2y, right? And so the answer should be 8 y to the 3rd. Because 2 to the 3rd is not 6, right? It's 2 times 2 times 2, which is 8. All right, 11. Anybody feel confident? Yes, Nathaniel. X to the 8th, y to the 12th. Perfect. Okay. All right, 12 is where it gets a little, just it's easier to make a mistake on 12 because there's more stuff there. And this piece right here, that exponent, anytime you have an exponent outside of a parenthesis, pay attention to that one. That's when the parentheses, everything in the parentheses matters. The parentheses do have a job, and you got to pay attention to that. So that belongs to this first part here, and everything has to be squared first before you multiply it with the second. You don't want to go 5 times 2, x squared times x to the 4th. That will get you lead you the wrong direction. Okay, so 5x squared y is repeated, and then we have 2x to the 4th y squared, and go ahead and multiply. Now there's nothing outside those parentheses, so then you could drop the parentheses if you have no exponents outside of that, and just multiply any which way you want. You could reorganize it. I'm going to go 5 times 2, which is 50. Count my x's, x squared, x to the 4th gives me x to the 8th. And y times y squared is y to the 4th. Okay, you guys try that on 13 and 14. All right, 13. What final answer? What is the coefficient? Coefficient means the number in front of all the variables. 96 is correct. Shrina, right? Shriya. I'm learning. Okay, good job. And then x to what power? Anybody? Yes. 13. Is it Joanna? Good job, Joanna. And then y to the 7th. What's your name? Elizabeth. Good job, Elizabeth. Okay. So there we have it. And kind of the order we go in. So this is 4. Well, did you guys, I mean, x squared x to the 3rd is the same base. So there's a couple ways to handle this. You could actually multiply those two together and get x to the 5th if you wanted. Squared. I'm going to rewrite this one. There's a variety of ways to handle this one. Create a little more space for myself. So everything in the first set of parentheses is squared. So it's 4 squared and x to the 5th squared. So that's 5 plus 5 gives me 10. Or you could go 5 times 2 is 10. And then times 6 times x to the 3rd times y. And so if you find out what 4 squared times 6 is, which is doable without a calculator, you get 96. You got 10 x's and 3 x's, so that gives you 13, and then 7 y's. I forgot to put the 7 here, though, didn't I? And there we have it. And then our last one, 14. What is the coefficient? Positive or negative? Good. It's positive because that negative 4 is squared, meaning you have two of them. Negative 4 times negative 4, which is positive, 16. 16 times 2 gives you the 32. And then x to the what power? 9. And y to the 4th. Okay. And so you have 2x y to the 4th times negative 4 squared times x to the 8th. And you put that together and you get this answer. And remember, if it doesn't have an exponent, there's a 1 there, right? Okay. So homework. You guys know what it is. It's to work through that worksheet and take that survey if you get a chance. You guys, just to let you know, you're always welcome here at lunch or after school, whether it's math related or you're just trying to escape the heat. I do allow food in here at lunchtime. Just to let you know, you guys are always welcome, okay? I'm looking forward to a good year with you. And I didn't tell you this.